Welcome to the lecture on annuities due and deferred annuities. So, in the previous lectures we discussed about the compounding factors, and we also discussed about the factors related to F and A or A and F, where A is nothing but the annuity. So, annuity basically is the equal amount monthly or yearly which is paid in any type of cash flow diagram. Now, there are cases, so as we know that these annuities are normally assumed to be paid at the year end. So, when we are discussing about cash flow transactions in the financial sector, then normally it is assumed that it is at the end of the time period. So, the first payment will be at the end of the first year. So, if we are starting from now, then once 1 year is over, then we are supposed to have first payment. So, that is the standard practice when we study these annuities. Now, many a times what we see that these payments are basically done. So, basically at initially itself. So, that is what the annuities due that case belongs to. So, annuities due means it is just like ordinary annuity, except that payments occur at the beginning of each term instead of at the end. Example, insurance premiums, property rentals, etc. So, there you have to have certain modifications. Now, before that once we so as we know that you have to give. So, just like insurance premiums, you are giving the insurance amount at the beginning itself, or rentals you are giving at the initial of the month itself. So, these are those examples. Before that let us have a quick look at the derivations which we did for the annuity, and we know that F by A factor was there, and it was basically 1 plus I raised to the power n minus 1 upon I, or many a times you will see that it will be represented by term R also. So, 1 plus R raised to the power n minus 1 by R. So, that is what is the F by A, and this is equal payment series compound amount factor, and that is how we define it. Now, if we have to find F, then we know that F will be A times this factor. Similarly, if we have to find A will be I upon 1 plus I raised to the power n minus 1. So, that way you can have values of these any of the quantity, but then we may require to find the term. So, to find the term of ordinary annuity. So, if we are talking about the annuities, then to find the term means you have to find the value of n. So, as we know that it is F is basically A into 1 plus I raised to the power n minus 1 upon I, and you have to have the value of I. So, this A is basically whole divided by. So, if you look at that, what will be there? 1 plus I raised to the power n minus 1 will be F into I upon A. Then you will have 1 plus I raised to the power n will be 1 plus F into I upon A. So, you will be taking the log on both the sides, and if you take the log, so n ln of 1 plus I will be ln of 1 plus F into I upon A. So, you can get n as ln of 1 plus F into I upon A divided by ln of 1 plus I. So, this way you can get the term of the ordinary annuities, and there may be questions based on some such kind of annuities, and you can find the solution for such annuities, like you may have for a business owner wants to buy equipment for rupees 60,000, and then he can save rupees 500 a week for future purchase. So how long it will take him to purchase, to have the amount in his account, then it is given that at the rate of 7.3/4% interest compounded quarterly. Now these are there are certainly some data which are we need to have more of its understanding maybe in our later lectures, because the interest rate is not compounded annually or not compounded weekly, basically it is compounded quarterly. So you will have to have these interest in the term of accordingly, because you have given as it is 500 a week, and then he has to have this amount for which that is 60,000 is to be deposited. So accordingly we have to adjust the rate of interest. Now what we see that you have to have this 7.3/4% interest compounded quarterly. So for quarterly interest it will be 7.3/4 and divided by 4. So that will be basically the interest per 3 months. So that will be there, and then he has to deposit this amount 500 a week for the future purchase. So accordingly you have to have that. Now the thing is that again you have to have this n, as we know that you must have the value of n to be fitting into ln of, as we know that you will have to have n as ln of 1 plus fv into I upon a divided by ln of 1 plus I. So this I basically you have to have the effective interest, and accordingly you have to put in. Now here you assume that he is saving 500 rupees a week. So basically he is going for 1 quarter, up to that he is saving, and then he is putting in the bank so that he can get the interest. So based on that, if you take quarterly interest will be basically 7.3/4 divided by 4%. So it will be it is 0.0775 divided by 4 further. So it will be 0.019375%. So this is for per quarter, okay. And then in a quarter we assume that he is saving 13 times the amount. So the amount A will be 13 times 500. So it will be 6,500. So 6,500 rupees he is saving for a quarter, and if in every quarter he has so that interest is basically this much, and in that case you can put it here. So it will be ln of 1 plus this is f final value, or f itself you can have. Fv is nothing but f, that is your 6,500, no, not 6,500, it is 60,000. So it will be 1 plus 60,000 and then into I. So it will be 0.019375 then divided by A. So, A will be 6500, and then you will have this ln divided by ln of 1 plus 0.019375. So, this way you can have these values, you can calculate, and what you, if you calculate these values, you will get something close to 8.6 quarters. So, in 8.6 quarters basically that person will be able to get this much. So, if you look at in otherwise, if 6500 he is accumulating in 1 quarter, in normal case it will be something like 52,000 plus 3 plus 4 something like 56,000, and then certainly because of the accumulated interest he will be getting 60,000. So, this way you can have the value of the the number of terms for the ordinary annuities. Now, we will be talking about the value of the annuities due. Before that, you can also have the finding of interest rates. So, from the same formula, you can also have the equation for the interest rates also on the annuities. So, that can be calculated from the normal formulas. Now, coming to the annuity due. So, annuity due, as we discussed, that here we assume that you are starting the value, the deposition or depositing the amount or transaction at the beginning of the time itself. So, in that case, what will be the future value? So, basically what is there, that you have one more extra period, and in that case the future value will be what you calculate using ordinary method, and if the R is the interest, then you have to multiply it with 1 plus R. So, that value will be changing, and this annuity due, in that case the future value FD or FVD, that will be basically, in a normal case you have A into 1 plus I raised to the power n minus 1 upon I. So, this is in normal case. Now, this payment, you have n payments and you are starting from the beginning itself. So, basically the you are getting in normal case what happens, that you are not you are starting the payment from here and going till here and then getting final here itself. Now, in this case you are starting from here and going up to here, so that in the end you will be getting the same amount. So, basically you will have the difference, basically whatever you have future value here being calculated, it will be multiplied with, so it will have one more interest period to its account. So, you will have to multiply with f by p factor, f by p I n, that is 1 plus r. So, I n is 1 itself. So, in that case you will multiply with 1 plus I. So, that becomes the case of annuity due, and that you can see one example. Suppose that a person is depositing, so a person is depositing rupees 550 in their savings account on first day of each month for next 5 years. So, if account pays 7% interest compounded monthly, how much they will collect at the end? Now, this person, as you know, that he has started saving on the first day itself. So, and he will be depositing that for 5 years, and he will, in the end he will have some money which is deposited. So, in this case what you see is that A is basically 550, and interest. So it is he is paying monthly, so you will have to have the monthly interest. Now the interest is 7% compounded monthly, so 7 by 12% compound, so per month. So in that case your number of terms becomes it has 12 month, and then for 5 years, so 12 into 5 it will be 60. So now he will be getting that in the end. So you will be you have to calculate it, and now this will be basically 0.0583%. So that will be the amount. Now if you calculate, if you put that in the equation, so this will be annuity due, so this will be future value due in that due cases. So it will be 550. So if it is A, so that is 550 into 1 plus I, so it will be 1.0583 raised to the power 60 minus 1 upon 1. So that is I is 0.05. So it will be basically 7 by 5% per month is 7 over 5 is itself is 0.583. So it will be 0.00583. It is basically 0.583%. So it will be, so this is I is 0.00583. So it will be 0.00583. So this will be also 1.00583 raised to the power 60 minus 1 by this, and then again you will be 1 plus I, so 1.00583. So this amount being calculated, that will give you the amount, and this comes out to be 39,606. So you can compute this value, and you can get these values. So if in normal circumstances, if you look at 550 into 12, so it is 64,600 multiplied by 5, it is 33,000. So but with interest earned, he is able to accumulate 39,606 rupees in this case. So that's the basic difference when the case is of annuity due, and we calculate the values in such a cases in this very manner. Now further, when we have to calculate current value in the case of annuity due, so in that case if you have to find the current value, so in the current value for these due cases will be A into 1 minus 1 plus r raised to the power minus n divided by r into 1 plus r. So basically it is nothing but you are dividing it by 1 plus r raised to the power n, and in that case you are getting that. So 1 plus I or 1 plus r, whatever you can say, or A into 1 minus 1 plus I raised to the power minus of 1 by I into 1 plus I. So what happens that here for getting the current value you have to divide it by 1 plus I raised to the power n. So in that case 1 plus I raised to the power n minus 1 by I into, so and that too divided by 1 plus I raised to the power n, so it will be 1 minus this term, and then this is the same thing, other thing hold good. So that way you can have the value of these current value in such cases being calculated. Now similar to that, we can also have the finding the payment of an annuity due. So payment of annuity due, and in that case you have to find the value of A. So as you know that if you know the F, then you have to simply get the A from there, and if you find A, that is for due cases, so we will have the subscript D for those cases, and it will be F into I upon 1 plus I raised to the power n plus 1 minus 1 plus I. So, as you look at the earlier cases, so in this case as you see it will be f d into I divided by 1 plus I raised to the power n plus 1 minus 1 plus I. So, that is what from here you can get these values. Similarly, you can have also the term of the annuity due cases also can be studied by finding the value of n in such cases. So, these are the only thing is that you have to have the consideration of 1 plus I or 1 plus R, whatever you take that nominal interest term. So, that is to be taken into account, and that is to be considered while finding either f or CV or AD, FD or CVD or AD. Now, we will talk about the case that is your deferred annuity case. Now, what is deferred annuity? Now, in the case of deferred annuity, it is nothing but the same annuity, ordinary annuity, but the payoff starts at a later time. So, basically the payment which is starting, it is starting at a later time. So, you are deferring it by a certain period. So, first payment is made after a certain time has passed according to the financial contract, and that period is called the deferment period. So, as you know that in many cases we talk about those periods where these we have to defer this time, like we take the loan in many cases and we try to pay the loan after few years when we are thinking that we will be getting job and then we will be able to pay it back. So that is the case of this deferred annuity. Now, in these cases what you have to do is that the simplest way will be that you find the current value or the principal amount or present value basically at the beginning time before taking deferred period into account, and then also you take the annuity values for the deferment period, and you can subtract the amount of p value which is resulting because of the deferment period payments, because that has not actually taken place. So, you can calculate these two values and then subtract one from the other. So, that is your deferred annuity. So, what you have to do is that if first payment is basically made at the fifth payment period, then so annuity is said to be deferred by 4 payment periods, because in the fifth payment you are doing. So, basically you are deferring for the 4 payment periods. So, you are, suppose you have go to ultimately total 20 periods. So, you will be finding the current value for 20 periods, and then you will be finding the current value for 4 periods, and the current value of 20 periods minus current value of 4 periods will give you the current value for the whole deferred cases. Now, so what I mean to say, better that this is time 0 and this is 1, 2, 3, 4, and it's going like n. Now, in this case suppose it goes from here, you are starting paying like this. So, basically this is deferred by 3 periods. So, you have to take first of all you take for whole values, then you can have the for this value and then subtract it. So, that way you can get the present value. Another way will be, there are many ways, and you can get the for such periods you can have the present value. So, you will have be getting the present value here itself, and then you can further map it to this place using the equivalence formula, which we will be studying later. But the whole concept is in that direction. So, you can have one example. An example is that to find current value of a deferred annuity of rupees 250 a month for 18 months from January 2008 to June 2009. If first payment is due at the end of April (2008) and interest rate is at basically 7% compounded monthly interest. So, what I mean to say here that basically this is the type of cash flow diagram which will be looking like, and it has it started from April. So, it means it is going from the 4th period, and n will be total 18 months. So, basically n is 18 here, n1 will be 18 and n2 will be maybe 3, something like that, and you have to first get the current value using this 18 value, and then another value will be n2 will be 3. So, we will be getting CV1 here and CV2 here, and final value will be CV1 minus CV2. So, I, if you look at I will be 7% compounded monthly. So, 7 by 12% per month. So, it will be 0.00583. So, it will be I, and you have to have this current value for the first case as well as the second case, and if you find the current value. So, current value will be nothing but A into, so A is given as A is given as 550, A is 250. So, you can put in the formula A into 1 minus 1 plus r raised to the power minus n divided by r. So, that will give you the CV1, and CV1 will come out to be for approximately 4927.85, and CV2 will come out to be approximately 741.34. So, if you calculate that, because you have to calculate it using CV will be A, so it will be 250 into 1 minus 1 plus I, that is 1.00583 raised to the power minus 18. So, it will be this, and that is divided by R. So, it will be 0.00583. So, this way you will be getting this value 4927.85, and when this n becomes equal to 3, then in that case you will be having. So, there is one thing which is to be seen in this case, that the person is basically depositing for 18 periods. So, this n will be basically 18 plus 3. So, that is 21, because he is giving for 18 periods, and his due will be over in so he will be getting at the end of September. So, it is ultimately it is 21. So, then it is coming as 4927.85, and when you are putting 3, then it is coming 741, and so ultimately it will be so as you know that since he is deferring by 3 months, so he will be going for later 3 months. Ultimately he has to deposit for 18 periods, and 3 periods he is not depositing. So, that is why it will be minus 21 here, and so it will be if you subtract them, it will be close to 4186 rupees. So, ultimately this is your answer. So, that is how these problems related to deferred annuities are solved. There are many ways otherwise to solve in such cases, because you can have the future values also got at certain time, and then that can be, you can have the equivalent amount at the present time or so. So, all these things can be done using these compounding formulas. Thank you very much.